Hello, my name is Anna E. Milosky, and this is my final course project for Human Factors in AI course. So, as I covered in the previous course, Managing Machine Learning Projects, I will again take a different look at online credit card fraud detection and prevention through the user experience and ethics lens. So, as we know, there's a huge opportunity here. $36.13 billion is lost to online credit card fraud globally. This is the 2023 estimate. Our target users are credit fraud analysts within financial institutions. And we also must consider the other side of the coin, who are the credit card holders. The key task is to correctly identify and prevent fraudulent online credit card transactions. So, all right, now let's take a look at our task analysis for fraud detection and prevention from the point of view of the fraud analyst. So first, the user receives an automated alert, email, text message, that there's been a potentially fraudulent transaction. The fraud analyst will then review the system-assigned fraud score and a customer history. The user then makes a decision, is this a potential fraud? So if yes, then we would continue on to contact the customer. This can be done via email, SMS, phone call, or through an app. So the system action, the action the system would take is to contact the issuing bank to block the transaction that's potentially fraudulent. So a decision is made with a customer response. So if the customer confirms not fraud, then the fraud analyst can inform the customer to retry the payment through any of the communication methods we previously mentioned. If the customer says it is fraud, then we can take actions to block the card, and upon the customer request, issue a new card. However, if there is no response, then the fraud analyst will collaborate internally to investigate further and potentially retry to contact that customer. So they'll be using the fraud UI that we'll see later, as well as there's a lot of internal communication going on. Now, if the customer doesn't respond after a certain fixed period of time, the same action will take place, just as if it had been fraud, to err on the side of security, to block the card. And once again, a new card will only be issued once the customer makes the request. In this workflow, we have met our objective of detecting and preventing the maximum amount of true fraudulent transactions. So what insights can we gain from the task analysis? So first of the opportunities is to reduce manual steps for fraud analysts and bottlenecks. So we can automate the review of that transaction and the decision to block the transaction using an ML classification model, and route the transaction accordingly based on the fraud score. So assuming 5 is the highest, and 1 is lowest, then if it's a 3, we pass for a human review. Otherwise, 5 pretty much just skip to blocking transaction. We can also accelerate the customer communication. So instead of the analyst having to manually call up, text, or email the customer, we can automate this process and provide 24/7 quality customer service with an AI-powered chatbot, which we'll see how that might look in the next slide, and use natural language processing so the conversation is as smooth as possible. We can also reduce customer frustration due to unnecessary blocks by training our machine learning model from historical data on transaction validity to reduce false positives. Lastly, we can add self-service options for our customers. So via an app or website, customers could review and confirm transactions to reinitiate or release the hold on their transaction. Similarly, they can do this through SMS, as I'll show on the next screen. So moving on to our UX design. The fraud analyst would see a cockpit, so sort of insight center, where they could monitor kind of overall fraud patterns for the set of customers or geographic region they're covering, and also dig into these little trends or anomalies that we see here. On the cardholder side, we could have a very natural, intelligent, AI-driven dialogue to get user input and to continuously train our model. So the cardholder, and this is their smartphone, they would receive a fraud alert, and of course we would have integration with a authenticator app for maximum security. So after they enter that code and the code is valid, then we can provide transparency to our customer and give them the information needed to make a decision on whether this is a fraudulent transaction and what to do next. So we can let them know that, all right, 2 minutes ago, someone attempted a transaction for $2,000 in Bulgaria, which is strange given the customer, in this case, is the United States, and the merchant is Useful Goods Inc., which doesn't sound very legitimate. So we can provide the customer with options where we can either let the transaction go through if they say process, or report the fraud and by replying fraud. So the customer here replies fraud, and then we can provide intelligently different options. So do you want to cancel the card, and other things such as speak with customer support. In our product design process, we have considered the 3 AI design considerations. First, user inputs. Second, transparency. And third is communicating uncertainty. So we collect the user inputs from the user response to the prompt from the fraud message via the smartphone. We also can include a way for the user to provide feedback on the system via SMS or the card app to continuously improve our system. We have a lot of transparency in our system, given that we explain why the transaction is blocked. We tell them, okay, this is in Bulgaria. We reveal the features involved in our decision and the values that trigger this fraud alert. And we can tell the user that their response to our fraud prompts will be used to evaluate future suspicious transactions. And of course, we'll be very transparent in communicating uncertainty. So we present this transaction to the user as a potential fraudulent transaction. And if the customer wishes to get more information, we can explain our key features and methodology driving the fraud classification in a privacy disclosure or web page that is easily understandable. So since we are gathering location information about spending habits, this could understandably raise concern with our users, particularly that potentially their info will be sold for ad purposes, which of course we wouldn't do. But let's go over how we've addressed the FIPS, Fair Information Practices, and privacy concerns. So regarding the rights of individuals, we are collecting personally identifiable information and sensitive information, given the transactions are, of course, financial in nature. So we can identify what information we're collecting and how it's used, of course, provide notice of our privacy policies, and get explicit consent through initial app screen to collect this information. Moving on to the information controls. Of course, as a large credit card company, say Amex, we will have policies and systems in place to safeguard PII, such as logging who has accessed the data, state-of-the-art, cloud security and encryption, etc. And We will also allow customers to review their PAI to make sure we maintain accurate and complete information. As part of the information lifecycle, we will make sure to use the PII only described in the privacy notification customers can read, and only keep this information for as long as possible, as long as is required for our purposes. Finally, PII management. We will document and communicate accountability for data privacy within our organization regularly, monitor compliance with privacy policies, and of course, institute procedures to address user complaints, such as transactions consistently being incorrectly flagged as fraud, etc. So, what are the applicable privacy laws? There are many more laws globally regarding data storage, privacy, but let's just take a look at the US and European Union. In the United States, we have individual state laws, most strict being California's. Consumer Privacy Act. We also have the Fair and Accurate Credit Transactions Act, the Gramm-Leach-Bliley Act, as this is in the financial domain. We have a payment card industry data security standards, as well as if any children are using these credit cards, the COPPA, Children's Online Privacy Protection Act, also applies, meaning that we need to get parental consent for collecting data from children under the age of 13. In the European Union, of course, we have the General Data Protection Regulation, GDPR. So what are the legal obligations? We have quite a lot of legal obligations as a credit card company that is operating internationally. Just to get into a few, we have a privacy rule under the Gramm-Leach-Bliley Act, where we provide required privacy notices in a standard format, allow users to opt out of external data sharing, as well as implement safeguards. So we have to have a comprehensive information security program, review this program annually, and also have administrative, tech, and physical safeguards to ensure confidentiality of the data. As a part of the payment card industry data security standard, we also must maintain a vulnerability management program, regularly monitor and test our payment network, and again, maintain an information security policy. Under the GDPR, we have many obligations as we are a data controller. As you can see, transparency, we can limit the usage, make sure this data is accurate, and also be accountable for data security. It's also of utmost importance that we ensure the rights of individuals. Very important to this course in machine learning is that individuals can opt in and opt out and reject automated decision making. So meaning that customers do have a right to have their transactions all manually reviewed if they do so choose so. A main source of bias, of course, is our data collection process, which is vulnerable to historical bias as well as sampling bias. So in US, historically, unfortunately, manual reviews often more frequently predicted people of color as committing credit card fraud, and women weren't allowed to apply for a credit card without their male relatives' permission until 1974, so we have less data from women. Therefore, our predictions may not be as accurate with this group. Label bias meaning that certain kinds of transactions could be more likely to be labeled as fraudulent. And finally, feedback loop bias, wherein the prejudices of fraud analysts who are doing manual reviews could provide input into the system and perpetuate, making our model less accurate and biased. So lastly, how are we ensuring ethical AI? We ensure fairness by gathering adequate data about each group, such as men and women, people in different parts of the world and ensure that we have the same error rates or accuracy rates across these groups when we are training and evaluating our model before deploying it. And as a major global company, accountability for us is key. So we will consistently test and evaluate our model after deployment, as well as conduct a regular review of user input from our feedback mechanisms and fine-tune the model accordingly. Furthermore, within our customer service department, we'll have a dedicated escalation process for user complaints and dispute resolution. Finally, we'll ensure transparency by informing users how their transaction data is being used via the privacy agreement. And also, as you saw in the user experience design slide, we'll provide users with reasons why their transaction is marked as fraudulent and give them the option to contact customer service if they want to learn more. Thank you for listening to my presentation. All rights are reserved, and if you liked what you heard, please feel free to connect with me at the address shown here. I'd love to hear from you. Thanks, and have a great rest of your day.